Hi, this is Nick from Aguazio, here to give you an overview of MLRun and how it facilitates simple containerization and reusable components. So let's get right into it. So one of the fundamental concepts of MLRun is the concept of an MLRun function. And it is essentially an abstraction that allows you to take code and turn it into a serverless function. Really powerful. So let's take a look at what exactly goes into it and how we would create one. So one of the aspects that go into this MLRun function is a name and a tag. Very similar to a Docker container where you would name it and you can have different versions based on these tags. You're also going to point it towards your code, wherever that is. We can do Python files, Jupyter notebooks, GitHub, even our MLRun marketplace. So just point it towards the code you want to run and give it a runtime. So how do we want to execute this code? From our perspective, we're just changing a simple configuration, so job or Dask or Spark. On the back end, it's creating different types of Kubernetes resources based on this that we just really don't have to think about. We're also giving it a Docker image. So what libraries and dependencies do we want to run in our container? And last but not least, resources. So memory, CPU, GPU, again, using high-level Python syntax to assign cluster resources to our job. So this here is an example of what this might look like. The Python API has a function called code to function, where in this case, I'm running my test.py file using the MLRun/MLRun image. And when it starts up, I want to run myfunc. That's the function I want to run. So this is all compiled into this MLRun function abstraction that we've called fn. And in order to run it, fn.run. That's pretty much it. So what this lets us do is create reusable components that we can use across multiple projects and even across clusters. The nice thing about it is it can be stored in GitHub. So we can create these abstractions, store them, push them to GitHub, and then use them across all of our different projects and our different clusters. So what this does is it gives us the benefit of containers without the complexity. On the right-hand side here, I have two examples of MLRun functions called fn, and I'm running it in two different environments just by changing the flag. So in the top one, it says local equals true, and this means I'm going to execute this function in my local environment, whether that's on my laptop or in Jupyter or my IDE. I can execute it there with the resources I have available in that environment. I can also change it to local equals false, which means it's going to run on my Kubernetes cluster with whatever resources I specify. This is really powerful for doing iterations and developing on your laptop and executing on the cluster when it's time to really put it out to production or when you want to test with a larger data set. So also what this lets us do is it makes it very trivial to switch between different runtimes. For example, Dask versus Spark. Obviously, you will still have to write your Dask or your Spark code. What I mean is the orchestration of those different frameworks is very simple. It also makes it easy to scale services up and down for accelerated and distributed computation. For example, you can specify the number of workers in your Dask cluster using high-level Python syntax. And what this is doing at the end of the day is abstracting the Kubernetes resource creation. Running a Spark job is very different from running a Dask job from the Kubernetes perspective, but from our perspective, we don't really care. And that's one of the points of creating this MLRun function abstraction, so we don't have to worry about that, and we can take care of it for you on the back end. All of this to say, we can use these MLRun functions to create fully orchestrated pipelines, both in batch and in real time. There will be other videos on both batch pipelines as well as real-time pipelines for more information. Just know that you can use these MLRun functions as components within a larger pipeline, again, both for batch and for real-time. So that's really what I wanted to talk about as a core tenet of MLRun, the concept of packaging up your code into an abstraction so you can use high-level Python syntax to configure your jobs and your real-time functions using the MLRun framework.
If you're interested in learning more about MLRun, you can check out the documentation, the GitHub repo, or the MLOps Live Slack workspace. We'll see you there.